Hi my friends, welcome again. Let's discover what is bilinear interpolation. When you resample or reproject data, you may have to use bilinear interpolation, bilinear resampling for your data. The most common resampling operators are bilinear interpolation, cubic convolution, and nearest neighbor. Today, we focus on bilinear interpolation, which estimates an output surface with for known values. How is it different from the other interpolation techniques? Let's take a look. In mathematics, bilinear interpolation is a method for interpolating functions of two variables, e.g., x and y, using repeated linear interpolation. It is usually applied to functions sampled on a two-direct linear grid, though it can be generalized to functions defined on the vertices of a mesh of arbitrary convex quadrilaterals. Bilinear interpolation is performed using linear interpolation first in one direction, and then again in the other direction. Although each step is linear in the sampled values and in the position, the interpolation as a whole is not linear, rather quadratic in the sample location. Bilinear interpolation is one of the basic resampling techniques in computer vision and image processing, where it is also called bilinear filtering or bilinear texture mapping. When do you use bilinear interpolation? Before we do a full-depth explanation of bilinear interpolation, it's important to know why you would use it in the first place. Temperature gradient rasters, digital elevation models, annual precipitation grids, and noise distance rasters are all potential examples of when interpolation can be used to resample images. Each example has values that vary continuously cell to cell to form a surface. Here are a couple of examples of when you would use bilinear interpolation. When you resample your data from one cell size to another, you're changing the cell size and would need interpolation. When you project your raster data to another coordinate system, you're changing the configuration and resampling your data. In both of these cases, you would use a resampling technique. Because when you have an input raster, how does the output raster know which cells to base the output on if the input cells don't match? You have to select a resampling technique such as bilinear interpolation, cubic convolution, or nearest neighbor. How bilinear resampling works. Bilinear interpolation is a technique for calculating values of a grid location based on nearby grid cells. The key difference is that it uses the FOU or closest cell centers. Using the for nearest neighboring cells, bilinear interpolation assigns the output cell value by taking the weighted average. It applies weights based on the distance of the for nearest cell centers, smoothing the output raster grid. Bilinear interpolation. It's recommended to use bilinear interpolation for continuous data sets without distinct boundaries. The surface must be continuous and the closest points must be related. When you run the process, it generates a smoother surface, but not as severe as cubic convolution, which uses 16 neighboring cells. The output raster will take only the for closest cell centers and apply an average using distance. Why use bilinear interpolation? The key difference in bilinear interpolation is that it uses for nearest neighbors to generate an output surface. On the other hand, cubic convolution uses 16 nearest neighbors, which smooths the surface more so. Bilinear interpolation assumes the input is continuous. This resampling method uses a distance average estimate with closer cells being given higher weights.